Welcome to Astronomy Daily. I'm Anna.
And I'm Avery. It is Monday, the 11th of May, 2026, and this is Season 5, Episode 99.
One episode away from triple digits, Avery, and we are not going quietly.
Absolutely not. Today we have 6 stories that run the full gamut. Mysterious fireballs raining down across continents, a rocket breathing fire in Texas, a cargo ship about to head to the space station, carbon molecules shaped like soccer balls appearing inside a dying star, never-before-seen photographs of the moon's far side, and, brace yourself, the biggest government UFO file drop in history.
That is quite a lineup. Let's get into it.
We're going to start with the story that had the internet absolutely buzzing over the weekend, and it is one that sits squarely in our wheelhouse. On Friday, the 8th of May, 2026, the Pentagon released what it called never-before-seen files relating to unidentified anomalous phenomena, UAPs, that the government has been sitting on for decades.
UAPs, for anyone who just joined us, is the official modern term for what most people still call UFOs. And Friday's release was genuinely historic.
It really was. The Pentagon launched a dedicated public portal, war.gov/UFO, and dropped an initial tranche of 162 files. That includes 120 PDF documents, 28 videos, and 14 high-resolution images. Everything from internal military memos to Apollo mission photography to recent infrared sensor footage.
The program even has an acronym, PURSUE, which stands for Presidential Unsealing and Reporting System for UAP Encounters. And the files span nearly 8 decades, going back to the late 1940s.
Now, before listeners get too excited or too skeptical, let's be clear about what the files do and don't say. The Pentagon was explicit. These are, quote, unresolved cases, meaning the government was unable to make a definitive determination on the nature of the observed phenomena. They do not prove extraterrestrial contact. They do not suggest a cover-up of alien visitors.
But what they do provide is transparency that researchers, scientists, and the public have been demanding for years. Former Pentagon UAP office head Sean Kirkpatrick cautioned that without analysis and context, the raw files risk fueling speculation. And that's a fair point. Context matters enormously with this material.
What astronomers and UAP researchers are most interested in is the ability to now cross-reference these files with existing scientific data, radar, infrasound, satellite records, to build proper analytical frameworks around what was actually observed.
Some of the more striking clips include a football-shaped object observed by an infrared sensor near Japan, a misshapen ball of white light recorded over Syria, and archival Apollo 17 imagery showing 3 lights above the lunar terrain that the astronauts theorized were ice chunks.
And this is only the beginning. The Pentagon says more files will be released on a rolling basis every few weeks as they are discovered and declassified. This is an ongoing process covering tens of millions of records.
For our listeners who want to explore the files directly, the portal is war.gov/UFO. No clearance required.
From government secrets to rocket fire, and what a fire it was. On Wednesday, the 7th of May, SpaceX completed a milestone that the entire space industry had been watching for. The first successful full-duration, full-thrust static fire of the Super Heavy version 3 booster.
All 33 Raptor V3 engines firing simultaneously for the full duration. SpaceX described it simply on X as full duration and full thrust 33 engine static fire with Super Heavy V3. Understated, but the footage was anything but.
And this matters enormously because previous attempts hadn't made it to this point. There was a 10-engine partial test in March, a 33-engine attempt on April 15th. Both ended early due to issues with ground equipment. This one went the distance.
The Raptor V3 engines themselves are a significant upgrade, each capable of delivering around 600,000 pounds of thrust with improved reliability over the previous generation. 33 of them firing together makes the Super Heavy booster the most powerful first-stage rocket ever built.
And the full Starship stack, that's the booster plus the ship upper stage on top, is over 400 feet tall, taller than the Saturn V, designed to carry more than 100 tons to low Earth orbit and fully reusable.
The ship upper stage for Flight 12 already cleared its own static fire earlier, so both halves of the vehicle have now passed their pre-flight tests. SpaceX is targeting the 15th of May for the 12th Starship test flight, a suborbital mission designed to further refine the vehicle's capabilities.
For context, Starship is central to NASA's Artemis program. It is the planned human landing system that would carry astronauts to the lunar surface. It's also SpaceX's primary vehicle for their long-term Mars ambitions.
So May 15th is absolutely one to watch. We'll have full coverage here on Astronomy Daily as that date approaches.
While Starship is preparing for its next flight, another SpaceX vehicle is heading to orbit tomorrow. NASA and SpaceX are targeting 7:16 p.m. Eastern Time on Tuesday, the 12th of May, for the launch of CRS-34, the 34th SpaceX Commercial Resupply Services mission to the International Space Station.
A Dragon cargo spacecraft will ride a Falcon 9 rocket from Space Launch Complex 40 at Cape Canaveral, carrying approximately 6,500 pounds of cargo. If all goes to plan, Dragon is scheduled to dock autonomously to the station's Harmony module at around 9:50 a.m. Eastern on Thursday, the 14th.
Now, the payload on this one is genuinely interesting. Among the scientific investigations heading up is something called the Laplace experiment, which studies how dust aggregates grow in protoplanetary disks. That's directly relevant to understanding how planets form.
There's also an instrument called STORY, Storm Time O+ Ring Current Imaging Evolution, which will monitor charged particles in Earth's magnetosphere. These are the particles that can affect satellites and power grids during solar storm events, so better monitoring has real practical value.
And then there's one that I find really charming, a wooden bone scaffold. Researchers are testing whether a wooden scaffold structure can support the development of new treatments for osteoporosis in microgravity. Space medicine is endlessly inventive.
You can watch the launch live on NASA Plus, Amazon Prime, YouTube, and NASA's own website. Coverage begins at 7 p.m. Eastern tomorrow, Tuesday the 12th. And while I'm giving a plug to things worth checking out, make sure you stop by our sponsor site, NordVPN. They have a truly great deal in place for our listeners at the moment. Find all the details by clicking on the link in the show notes. NordVPN, it's the one we use and highly recommend.
Now, for a story that is equal parts beautiful and scientifically profound, the James Webb Space Telescope has delivered stunning new images and data from a planetary nebula called TOC-1, located more than 10,000 light-years away in the southern constellation Era. And what it found there will keep astrophysicists busy for years.
The story begins 15 years ago, in 2010, when a team led by Professor Jan Kami at Western University in Canada made a remarkable discovery using NASA's Spitzer telescope. They found buckyballs inside TOC-1, that is, molecules of Buckminster fullerene, named after the architect Buckminster Fuller, who designed geodesic domes, because the molecules share exactly the same structural geometry.
Each buckyball molecule is made of 60 carbon atoms arranged in a perfect pattern of hexagons and pentagons, like a hollow soccer ball at the molecular scale. They were first synthesized in a laboratory in 1985, a breakthrough that earned the 1996 Nobel Prize in Chemistry. Finding them in space was extraordinary.
But Spitzer's resolution wasn't sharp enough to show where the buckyballs actually were within the nebula. Now, JWST has returned with its mid-infrared instrument, MIRI, and the result is breathtaking. The new image reveals delicate rays, wispy filaments, shimmering shells of gas, and at the heart of the nebula, a feature that looks unmistakably like an upside-down question mark.
Which the researchers found rather appropriate given how many questions the data raised.
The key scientific finding is this: the buckyballs are not scattered randomly throughout the nebula. They are concentrated in a thin, spherical shell immediately surrounding this central white dwarf. the stellar remnant at the heart of TC1. In the words of the PhD student who mapped them, buckyballs arranged like one giant buckyball.
Why they gather in that specific formation is now one of the central mysteries the team is working to solve. And there's another puzzle. The infrared signals the buckyballs produce don't match current theoretical models. Something about their formation or behavior in this extreme environment isn't fully understood yet.
TC1 is what remains after a star similar to our Sun exhausted its fuel and shed its outer layers. That process sculpted the intricate structures JWST is now revealing. Because buckyballs have also been found in meteorites that have landed on Earth, understanding how they form in environments like TC1 gives researchers clues about how organic chemistry, the chemistry relevant to life, spreads across galaxies.
The image itself was processed by Caitlin Beecroft, a secondary school science teacher and amateur astronomer, who met Professor Cami at outreach events. Her skill at drawing detail from raw telescope data is remarkable. It's a lovely reminder that extraordinary science doesn't always happen only inside institutions.
This next story is a beautiful combination of science and artistry, and it began with a direct message on social media. Just weeks before the Artemis II launch window, astrophotographer Andrew McCarthy had an idea. What if he could get the Artemis II astronauts to photograph the moon the same way he photographs the moon?
So McCarthy slid into the DMs of Commander Reed Wiseman, and remarkably, Wiseman was immediately on board. The two developed a detailed photographic plan with NASA's lunar photography team, who were already training the crew on camera techniques for the mission.
McCarthy's signature technique is image stacking, combining multiple exposures to dramatically reduce noise and reveal subtle color variations that a single image simply cannot capture. Those color differences across the moon's surface indicate different mineral compositions. Run enough stacked images through processing, and you get rich maps of the lunar geology in browns, blues, and reds, colors that are really there but too subtle for the human eye to detect unaided.
The key advantage Wiseman had over any ground-based astrophotographer, including McCarthy himself, was the absence of Earth's atmosphere. No distortion, no light pollution, no interference. The raw data quality from lunar orbit was in a completely different league.
The result is a set of images showing the far side of the moon in greater detail and color fidelity than has ever been achieved before. NASA has now released the full archive from the Artemis II mission, over 12,000 photographs taken by the crew during their 10-day journey. McCarthy's processed versions of Wiseman's lunar far side shots stand out as some of the most stunning in the entire collection.
McCarthy described his approach beautifully. He said, "I don't want to show you something the way your eyes see it. I want to show you something as if you had superhuman vision. The camera becomes cyborg eyes for our vision." And looking at these images, that's exactly what it feels like.
For our listeners interested in exploring the full Artemis II archive, NASA has made all 12,217 photographs publicly available. The link is in today's show notes.
And we close today with something that has been building across the news landscape for the past few weeks. A story about rocks falling from the sky and the growing scientific alarm about why there seem to be so many more of them than usual.
The American Meteor Society, the AMS, has published a detailed analysis of fireball activity in the first quarter of 2026, and their conclusion is direct. The data, quote, warrants serious investigation.
Now, let's be precise about what's being observed, because the statistics here are subtle but striking. The total number of fireball events in Q1 2026, around 2,046, is only marginally above comparable periods in previous years. The anomaly is not in the raw count, it's in the size and intensity of the events.
Mike Henke, operations manager at the AMS, put it this way. After years of stable baseline activity, something appears to have shifted. The signal is consistent across multiple metrics. The events getting flagged are the largest, loudest, and most widely witnessed fireballs, not the small, routine ones. Those look normal. The big ones are happening far more frequently than expected.
March 2026 was particularly dramatic. Over 40 major fireball events were recorded that month alone. The biggest single event was on March 8th, a slow, long-duration fireball over France, Germany, Switzerland, Belgium, and the Netherlands that generated 3,229 witness reports.
3,229 people reporting the same fireball.
Then there was the March 9th fireball, seen by 282 people along the eastern U.S. seaboard, a 7-ton asteroid fragment that exploded over Ohio with the force of a sonic boom heard across multiple states. And on March 21st, a fragment crashed through the roof of a home in North Houston, ricocheted around a bedroom, and landed intact. 3 confirmed meteorite recoveries in under 2 weeks, when the global average is roughly 10 per year.
The sonic boom data is particularly telling. In the first quarter of 2026, 30 out of 38 fireball events with 50 or more witness reports produced confirmed sonic booms. That's 79%. Sonic booms mean large, fast, dense objects penetrating deep into the atmosphere. That's not camera bias or reporting enthusiasm. That's physics.
Researchers have identified 2 suspicious clusters in the trajectory data. The most prominent is from the Anthelion sporadic source, a region of space directly opposite the Sun, where objects approaching Earth from behind are penetrating the inner solar system. Activity from this specific slice of sky has roughly doubled in 2026. Nearly 10 major events traced back to a single 1,000 square degree patch.
There's also an unusual cluster of meteors arriving on steeply inclined, almost vertical orbits, which is characteristic of objects traveling on trajectories quite different from the flat plane of the solar system. Both clusters are being studied closely.
What doesn't explain this? The AMS has been thorough in ruling out the easy answers. It's not a new meteor shower. Anthelion objects don't form those. It's not seasonal variation. There is a known fireball season around the March equinox, but the spike in 2026 is roughly double what that seasonal effect would predict. It's not reporting bias from smartphones and doorbell cameras. Those would boost numbers across the board, not specifically at the large fireball end.
And it's not extraterrestrial. The recovered fragments from Ohio and Germany have been identified as achondritic HED meteorites, one of the most common categories of space rock. Ordinary meteors, just more of them than there should be.
The AMS is calling for expanded automated all-sky camera networks that can independently calculate a rock's mass, velocity, and orbit the moment it strikes the atmosphere. Better cross-referencing with radar and infrasound data, and systematic analysis of recovered fragments to build a more complete picture of where these objects are coming from.
One thing worth mentioning for our Southern Hemisphere listeners, including many of you in Australia and New Zealand, the Anthelion source sits opposite the Sun, which means it's observable from both hemispheres depending on time of year. The phenomenon is global, not just a Northern Hemisphere event. Keep your eyes on the sky.
That is a remarkable episode to land so close to our 100th. Unexplained fireballs, the biggest rocket fire in history, a cargo mission to the space station, molecular soccer balls inside a dying star, the moon as you've never seen it, and the government finally opening its UFO filing cabinet.
Episode 100 is going to have a lot to live up to. Thank you for joining us today on Astronomy Daily. If you enjoyed today's show, please subscribe, leave a review, and share it with a fellow space enthusiast. You can find us on all major platforms through astronomydaily.io or search Astronomy Daily wherever you get your podcasts.
Until next time, keep your eyes on the sky.
And importantly, your mind's open to what's out there.
Rear skies, everyone.